Belgium has started work on the world's very first artificial energy island. It will store power from massive wind farms and send it all across Europe. 45 kilometers out in the North Sea, no one will actually live here except the fleet of robot dogs. It's the start of a huge plan to turn the North Sea into an energy grid that could soon power most of the continent. And it became even more important after Russia's invasion of Ukraine. But now the whole plan could actually collapse. Hey, I'm Louis. This is Megabuilds, and today we'll take a look at Princess Elizabeth Energy Island and the future of offshore wind in Europe. Let's jump right into the big questions. Why does Belgium even need an energy island? Well, they are already a major player in offshore wind energy. The country hosts 8 functioning offshore wind farms, and it ranks 7th in the world in offshore wind power, a big lift for a small nation. In 2016, Belgium and 8 other North Sea countries agreed to develop wind energy together. Their plan eventually became the North Sea Wind Power Hub, a framework for turning the sea into a massive wind power energy grid. It's a hub-and-spoke design. Wind farms would connect to power stations that can transfer energy between countries. Even landlocked Luxembourg has bought in. With no coastline at all, they committed to buying energy from the North Sea Wind Power Hub. It's all part of an effort to help Europe meet its carbon emission target set back in Paris 2015. But the plan truly kicked into high gear in 2022. That's when Russia invaded Ukraine and dramatically reduced its natural gas supply to Europe. Thus, at the 2023 North Sea Summit, Belgium and 8 other countries agreed to quadruple wind energy by 2030 and increase it tenfold by 2050. All of that would take thousands of new wind turbines and a reliable grid allowing the energy to be used and also traded. So when one country has excess wind, it can send their energy to a partner that has less. All of this takes energy hubs. And for offshore wind energy, those hubs need to be offshore too, meaning islands. This island in particular will serve as the hub for 3 new offshore wind farms in an area dubbed the Princess Elizabeth Zone. Southwest of Belgium's existing wind farms, the zone will include hundreds of new turbines. In total, it promises to handle 3.5 gigawatts of wind energy. In the middle of it all sits Princess Elizabeth Energy Island. But what does it actually do? The answer is actually quite simple. It's all about making the transmission of energy more efficient. You see, it will collect the energy from the 3 new wind farms in the zone and then send it back to the mainland. Sending the energy back to Belgium with a single set of cables rather than a set for each wind farm is already more efficient. But that's not all of it. If you have ever heard of AC and DC, you probably know what's coming now. For everyone else, here's a quick explanation. The Princess Elizabeth Energy Island is designed to handle both alternating current and direct current electricity, and there's a good reason for that. AC is the type of electricity most people are familiar with. It's great for short-distance transmission like powering homes and businesses. But transporting electricity over long distances, like in this case, is a different story. Here, DC is much more efficient as it loses less energy along the way, which is key because, in addition to sending energy back to Belgium, the island will serve as an energy hub with other countries. A giant transnational cable called Nautilus will connect the island to a British energy hub, and one called Triton Link will connect to Denmark's planned hub. Former Belgian Prime Minister Alexander De Croo highlighted the importance of the project. The North Sea is set to become the powerhouse of our energy independence, and Princess Elizabeth Island will be a crucial part of this process. It's the first step in a planned North Sea energy grid that by 2050 will generate 300 gigawatts. Belgium claims that this much power will meet the needs of 300 million homes, more than exists in all of Europe. The construction of Belgium's energy island is no small feat, but why build it on an artificial island? Mainly because Belgium has no natural islands on the North Sea. So before the project developer can do any electrical work, they need a man-made structure to hold it all. It starts with giant caissoons, huge concrete pillars that create the entire structure of the island and are anchored to the seabed 18 meters down. The first 2 caissoons were installed and connected in April. And let me tell you, these caissoons are enormous. Each one is 58 meters long, up to 32 meters high, and weighs 22,000 tons. It takes a team of up to 800 people to do the work and 3 months to build each caisson. The whole workflow is designed to keep as much of the work as possible on land. Concrete is poured 24/7 using a special cast that slides up to 8 to 10 centimeters each hour as the caisson grows. It's made from a special sulfate-resistant cement designed to endure the specific chemistry of the North Sea. Once completed, each caisson is towed by 4 tugboats to the site of Princess Elizabeth Island. When it gets there, dredgers will fill it with sand and water that sinks it down, and then it's reinforced with rubble. A total of 23 caissons will form the island's perimeter, and a high wall will be built around it to protect it from strong waves and wind. Once this perimeter is complete, dredgers will fill the core of the island with sand, 3 million cubic meters of sand to be exact. It's all compacted into place with a process called vibroflotation. Basically, a probe goes into the sand and shoots water sideways and then shakes all that wet sand into place. This technique makes sure that the sand fill is properly densified and provides a stable foundation for the island. Once the island's sand filling is complete, builders will install a concrete plant on the island for the sole purpose of covering the surface. And there we have it, the end result is a 6-hectare island with completion scheduled for 2028. Also included are a small harbour and a helipad allowing staff to maintain the island. But when people aren't there, the project developer plans to maintain the structure with robot dogs. Yes, you heard that right, robot dogs. They have already been tested on offshore platforms to see how they cope with wind and waves. Once they're on the island, the dogs will inspect facilities and send images back to the mainland, a man-made island populated with robot dogs. Kind of sounds like a Pixar movie. Once the basic structure is complete, workers will move on to the energy infrastructure. That's where the substations come in that turn the AC energy to DC energy for transmission to the mainland. As a final step, the island's engineers will build landing points for the eventual connections with the UK and Denmark. But all of this construction is surely bound to have some environmental impact. Though the engineering team has taken steps to reduce the negative impacts of the project, they're using an ultra-low-carbon cement, reducing the project's carbon footprint by 40%. And they've also taken steps to add positive contributions to the environment. This so-called nature-inclusive design includes ways to help marine life flourish around the constructed island. 3 small ledges will be built onto the seawall surrounding the island designed to attract black-legged kittiwakes. Apparently, that's a kind of seagull. I'd never heard of it either. Engineers have also designed artificial reefs around the 4 corners of the island. There, they'll add irregular surfaces both to the seafloor and the island's foundation. It's an attempt to create more surfaces for shellfish to attach to and more diverse conditions for life in general. They'll kickstart these new reef ecologies by building raised oyster beds. Once life takes hold on the artificial reefs, it can help protect the island structure from erosion. The project developer claims it's a win-win approach, though some environmental groups are not quite convinced. They are concerned that the full impact of the project on sea life and fisheries is still unknown. But overall, the island has had support from those eager to phase out fossil fuels. Unfortunately though, there are other bigger challenges ahead. The cost estimate for the project has spiraled from around $2.5 billion in 2021 to more than $8 billion at last count. Some of that is inflation, but the majority of the price hike is caused by a supply squeeze in the DC part of the project. There are only a few companies building DC substation equipment. And with so many countries now building offshore wind projects, the prices are shooting through the roof. So much so that energy buyers are spooked. In January, a trade group of energy consumers called for a stop to construction and a redesign. Shortly after, the construction company hit the brakes on the expensive DC component. Then in June 2025, it was officially cancelled. None of this impacts the caisson work already underway, but it dramatically affects when this energy island will ever come online. The latest estimates called for a 2032 launch, but that could have only happened if the developer proceeded with the contracts they just put on hold, and the original plan called for the island to go online even in 2030. But to be honest, that was probably always a stretch. The potential for a North Sea wind energy grid is impressive, but that grand plan is increasingly falling into doubt, and other countries are facing similar issues. Just last year, Denmark also postponed its plans for completing its energy island until at least 2036. Then, at the beginning of 2025, they halted their wind energy financing plan and announced they would go back to the drawing board to rethink wind energy. The future of North Sea wind energy is definitely a story in flux, and at this point, it's anyone's guess how the story will end. What do you think? How much of the plan will become reality? Let us know your thoughts in the comments down below. Thank you so much for watching until the end. I really appreciate it. And as always, we will see you in the next one.